Hey everybody, this is Larry. This is day 18 of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's form. 1337, I guess that's Leap. The K weakest rows in a matrix. Given an m by n binary matrix of zeros and ones, the soldiers are positioned in front of the civilians. That is, all the ones will appear to the left of all the zeros. Okay. Return the indexes of the kth weakest row in the matrix, ordered from weakest to strongest. Okay. Man, I'm getting pings from where? Let me turn it off real quick. Hopefully that did it. If not, maybe not. Alright. Yeah, I mean, this is a sorting problem. I think. Yeah, I mean, I think this is this is clearly a sorting problem. I think there is a couple of ways to think about it. I think in problems like this one, where the comparison function might actually be yeah, the compare function is kind of expensive, right? Because you're looking at each row, and if you're going to do a comparison based thing and you look at each row, that's not going to be, it's going to take O of C, per comparison, right? Though nowadays people, most things are actually not sorted with comparison by a key value, so we can definitely do that. But here for this particular problem, we actually want the K weakest row and not sorting. Why did I say you were sorting? Huh? Okay. I misspoke. My apologies. I misread. Oh my. I feel like I've been misreading a lot lately. And if you kind of follow me on my last contest, the weekly contest, you'll see that I spent a lot of time misreading, and that really cost me a lot of MMR. But I mean, I want to say I don't care per se. Like, it doesn't matter. But of course, like, if you're gonna be doing a competition, at least in the moment, you should care. But in any case, yeah, reading issue. Okay, so today, yeah, the K weakest. So now that we're doing K weakest, then of course we want to, yeah, we want to use a heap, right, or priority queue, and just keep track of the K, yeah, the K weakest rows, right? So what are we trying to? So is it a max heap or a min heap, right? So we want to remove the number that is the strongest. So that means that we want a max heap, right? Okay, cool. I think that's really all the preparation we need. I think the other thing that I kind of alluded to in the beginning is that we probably just need to we need to do a little bit of caching, but that's it. I mean, nothing to, or not even caching, just pre-calculation, so that we don't have to kind of calculate this all the time. But I think that's fine, right? Have the same number of soldier and I minus J I. Okay, so the tiebreaker is the earliest. Okay, so yeah, so then for I in range of. All right. So now we have a heap, and we want a max heap. In Python, we start with a min heap, so we have to do a little bit of a shenanigans, but that's fine. Oops. So we want to push just the index, and then, well, yeah, and then count of I, say, and then maybe the negative of it so that we got the max version. Yeah, and then if length of, oh yeah, that's the syntax is always a little bit off. If length of h is greater than k, then we just pop, we get rid of the max element, right? So that's it, and then we can return just the indexes. So we can return index for index. Now we want index for index in h, right? And that should be good. Of course, we have to write the count function, but the count function is pretty straightforward, right? You can actually, I mean, you could just do a count number of ones, but this one we can take advantage of the fact that all of them is to the left. So yeah, C is equal to 0. While matrix of index of C is equal to 1, and if C is less than C, that's actually confusing. But okay, fine, right? And that should be good, at least in concept. Let's take a look. Oh yeah, of course. I think I got confused. I'm very easily confused apparently. Do we have to do it in order? Oh, we have to order it. Okay, that's my fault. I actually did not realize that. Or I just kind of, I don't know. Yeah, so let's just say answer, right, is equal to, so then while length of heap is greater than 0, answer dot append heap q dot heap pop of h. Yeah, I guess we can do something like this, and then we have to reverse it, right? Just like yeah. Huh. Oh. Because the index is not max. I mean, I actually intended this to be min, but so that you keep the smaller element. Yeah, I did intend it to keep the smallest element in here, but then you reverse it, so that's why it is no bueno. Huh. Let me think about this a second. I'm just the reason why this is off is because we you know, in Python this is a min heap, and that's why there's a lot of confusion. I think if we were able to get a max heap, then but I think because we're doing a max heap, or not even, we're still doing a min heap, so that it mins by this, which is kind of a funky thing. But then now the tiebreaker is going to be on this if this number is the same, and here is still the min heap, so it still pops off the minimum element. So okay, so we just have to, I guess, also do the same thing with that, and I think that should be good. I just want to make sure that, like, you know, when we make changes, I didn't want to you know, just kind of cargo code it, you know, trial and error, right? Trial and error is fine, maybe if you have like a time constraint on it in terms of like being on a competition, but you know, when you have time, try to understand what the changes are you're doing and make sure that you're okay with it. And the reason why we have to reverse it is because this is a max heap, so this is a max heap, so it will always return the maximum element. So to kind of, you know, do reverse, we just reverse it. Let's give it a submit. Hopefully I didn't make a silly mistake, and yes. Alright. Much faster this time for some reason. Actually, what did I do last time? Last time looks okay. Yeah, this is the same idea. Actually, even the same code, really. Don't know. Maybe it's just a rounding error. But yeah. What is the complexity, right? The count function is O of C. So there's going to be O of R, and each heap is going to be log of K, because there'll be at most K elements in the heap, right? Otherwise we pop. So that means that this is O of R times C times log, oh no, it's actually O of C plus log K, right? Because it does this and then this, so it's not like it does both. And then just O of log K at the end, but that's already dominated by this. So yeah, so that's the time. Oops, that's the time and the rhyme. And in terms of space, this is just O of K space. We just have, we don't really use anything R or C, right? It's just a heap. Cool. That's all I have for this one. Let me know what you think. Still a little bit messy today, but yeah, gonna take a nap. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.